So let's get back to vectors. So we talked about vectors in the last video. Now we always remember we've got a vector and it's got an x value and a y value, and we can show it on a plane. So x is going to be 5 and the y is going to be 8, and that would be your vector. And we talked about how to get the, if you draw a straight line down here, we can get the angle because we've got the opposite side and we've got the adjacent side, and we can use Pythagoras to get the magnitude. So this is going to be the magnitude of u. So one thing that we want to talk about is unit vector. So unit vector is basically a vector that's in the same direction as this vector, but the magnitude of that vector is always going to be 1. So to get the unit vector, we need to get the magnitude of the vector, which is 5 squared plus 8 squared, which would be 25 plus 64, and that's going to be 8 square root of 98. So if we want to get the unit vector is basically going to be the same vector coordinates, so it's going to be 5 and 8, but you need to divide it by the unit vector. So that's going to be our coordinates. So you can test this quickly. I'm just going to show you now. If we want to get the magnitude of this vector, it's going to be 5 over square root of 89. Let's check the magnitude of this unit vector. Plus 8 over square root of 89 squared, and we get the square root of that. And we know this is going to be 25 over 89 plus 64 over 89. And if we add these two together, we will get 89 divided by 89 square root. So this will be 1. So you can see the angle or the magnitude of your unit vector would be 1. So with vectors, we also need to do some calculations. So let's take two vectors, u equals 1 and minus 3, and v is going to be 2 and 1. We can add two vectors together, and what we need to do now is we just need to take the x values and the y coordinate or the values and add those together. So to do this, we're going to say 1 plus 2 is 3, and minus 3 plus 1 is minus 2. So you'll see we just do the addition of the x and y values of those two vectors to get the new vector. So this is similar to get it. You can also use this with graphically. If we want to draw this, it will be 1 minus 3, which would be in that direction, and 2 and 1 would be in 2 and, okay, let's just draw this a bit better. Let's get our scale right. So it'd be 1 in the x direction and minus 3 in the y direction. It's going to be something like this. And the other vector is going to be 2 in the x direction. There's 2 and 1. So it's over there. So that's the other vector. So we can get the sum of these two vectors by starting at the endpoint of the first vector and drawing the second vector. So this is going to be the same magnitude, same direction, and our answer would then be from the origin to that new point there. And in this case, it's going to be 3 and minus 2. So you can add, it's a head and tail method. So we take the head of the first vector and put the tail of the second vector on that vector to get the other vector. So we can also multiply a scalar value. So we have scalar multiplication, and that basically is something to like this, 3u. So you take your 3 and you multiply it by the two coordinates. So it can be 3 times 1, which is 3, and 3 times minus 3, which is minus 9. So that's going to be the scalar multiplication. So addition and subtraction and multiplication, and then when you get to a very important next point, which would be multiplication of vectors. Multiplication. Okay, so there's two types of multiplications. Today we're just going to do one part, which is the dot product. We can look at what the dot product is, but there's also a cross product. And I'm going to leave that for another video, because we're just going to start with dot product today. So if we look at dot product definition is basically if we take one vector and we've got another vector, and we draw a line from the one vector perpendicular to the other vector, and say this is u and this is v, or a and b, or whatever you want to call it. So unit dot product is basically looking at these two vectors and seeing, if you look at the u vector, what is the size of the u vector in the direction of the other vector. So you want to basically check if this is the magnitude of u and this is the magnitude of v, the length of this vector, and we want to now see what is the x value of this vector in the direction of the v vector. So if this is the angle between the two vectors, to get this value, it's going to be opposite over, actually it's going to be adjacent over hypotenuse, and that is going to be the cosine of theta. And we know that a in this case is going to be the adjacent part, is what we want to calculate, and the hypotenuse is the magnitude of u. So if we want to get the value of a, which is multiplied by the magnitude of u, and then cos theta. So dot product is the magnitude of the one vector in the direction of the other vector multiplied by the other vector's magnitude. So dot product, let's say the dot product of u and v, and we use a little dot to indicate dot product. We're going to say it's actually the magnitude of v multiplied the magnitude of u, and then also, let's make that a better u, cos theta. So this is the definition of dot product. It's basically the direction of the one vector in the direction of the other vector, the magnitude of the one vector in the direction of the other vector, multiply the other vector's magnitude. There's also another formula that we use. If we've got the coordinates, say this coordinates is 2, 3, and this coordinates is 6, -1. To get the unit vector, if you've got the coordinates, you can just say it's the x multiplied by the x of the other vector plus the y of the first vector multiplied by the y of the second vector. So in this case, it's going to be 2 times 6, 2 times 6, get that times right, plus 3 times -1. And the answer is going to be 12 minus 3, which would be 9. So you can see the answer of a dot product is always going to be a scalar value. So the answer is not another vector, it's just a value. Of course, remember, it's the magnitudes of these two vectors that's being multiplied together. So there's a few applications that we can use with this dot product. So one of the applications is to calculate if two vectors are perpendicular. So you'll see if you've got two vectors and in these directions, if you get the magnitude of this vector multiplied by that vector, and this vector, the angle is a bit bigger with the same magnitude, you'll see the value on that with regards to the other vector is always smaller. And if you get to 90 degrees, you'll see that this vector doesn't have any value in that direction. So this value will always be 0 in that direction, multiplied by this vector. So if you look at this is maybe A and B. If you get the dot product of these two, the angle of the A and the cos of, in this case, 90 degrees, which is pi over 2, multiplied by the magnitude of B. So the cos of 90 degrees is always 0. So 0 times this will be 0. So the answer will just be 0. So this is very important. So if the dot product of two vectors is 0, then we know that these two vectors are perpendicular. So we can quickly check if two vectors are perpendicular. So let's say we take an example. A is 2 and minus 2, and B is equal to minus 4 and 4, and we get the dot product if these of these two. We say 2 multiplied by let's make this plus 2. 2 multiplied by minus 4, which is minus 8, and 2 multiplied by 8 is going to be plus 8, and this will be 0. Therefore the A is perpendicular to B. So that's a very nice example of using the dot product. There's another application that we always also use, and we're going to use the formula for dot product, the definition, magnitude of A, magnitude of B, and cosine of the angle between the two vectors. But we also know that we can get this by using the x value, and we multiply the y values of these vectors. So if we take an example of, let's take another example. We've got two vectors, and this vector is maybe 2, 2, and this one is 4, minus 1. And we want to calculate the angle between these two vectors. So we want the angle between two vectors. So we're going to use these formulas to check if we can calculate this. So we can get the magnitude of A. So this value we can get. We can get the magnitude of B using the coordinates. So we've got that. And if we've got the coordinates, we can also get the dot product with this formula. So we can get that one, and then we are just left with the theta, which we can then calculate. Good, so let's see. If we make theta the subject of this equation, we divide by the magnitudes. So we've got A dot product of B divided by the magnitude of A and the magnitude of B. And then we want to get the cosine, or the arc. So cosine of theta is going to be this. So to get the arc, we can just, the angle, we can just substitute the dot product. So let's calculate this quickly for this vector. Let's start with the magnitude of A. It's going to be 2 squared plus 2 squared, and we get the square root of that. So that's going to be 4 plus 4, which is 8, so square root of 8. And B, the magnitude is going to be square root of 4 plus the square root of minus 1 squared. That's going to be 16 plus 1, and that's going to be square root of 17. Great. And we can get the dot product. So the dot product of A and B is going to be the x values multiplied, which is 2 times 4, which is 8, and 2 times minus 1, which is minus 2. So this is going to be 6. Then we just substitute. So we've got 6 divided by square root of 17 multiplied by the square root of 8. So that's going to be cosine. And to remember what we said is, if we want to, let's just take this out. If we want to get the angle, we're going to use arc cos of this value. So on your calculator, do second function cos, and we put in our 6 at the top, and then we put our square root of 17 times the square root of 8 in this case, and then the answer is going to be, so theta in this case is going to be 1.03 radians. So you can see we can use the dot product to calculate the angle between two vectors by first getting the magnitudes, getting the dot product, and then using this formula to get the angle. And that's all that I have for you today.